This video is for section 1.7 in the Hawkes Pre-Calculus textbook on quadratic equations. Some of the objectives of this lesson are to solve quadratic equations by factoring, solving perfect square quadratic equations, solving quadratics by completing the square, the quadratic formula, and then some problem solving. First of all, a quadratic equation is an equation that looks like this. It's got ax squared plus bx plus c, where a, b, and c are real numbers, and a is non-zero. Pause the video and see if you can figure out why a cannot be 0. A can't be 0 because if a is 0, then we have 0 times x squared, and then we're just left with a line, bx plus c, rather than a quadratic equation. To solve a quadratic equation by factoring, what we want to see is something of the form x times x plus 2 equals 0. If it's already factored, then we can simply say that, well, if two things have to multiply to give me 0, then one or both have to be 0, since 0 times 0 is 0, and anything times 0 is 0 as well. So we split them up and we say x is equal to 0 or x plus 2 is equal to 0, and we solve them both. X equals 0 is already solved, so we solve the other and we find that x is equal with -2. What if we had something that wasn't already solved? Well, then our goal is to get this polynomial in factored form, and then again set each of those equal to 0. Okay, let's move on to completing the square. So if we go back to our ax squared plus bx plus c equals 0, our goal is to make this a perfect square trinomial. So what the heck is a perfect square trinomial? Well, imagine you had x squared plus 6x plus 9 equals 0. This is a really nice one because this factors into x plus 3 times x plus 3 equals 0. And we could write that even simpler if we want as x plus 3 squared equals 0. Now we agree, not all of our trinomials are going to look like this, but if we could make them so, that would be tremendously helpful in solving some later problems. So we'll start with our ax squared plus bx plus c. Let's make it x squared plus, we'll do 8x plus 13 equals 0. Now I don't know about you, but I can't factor this one. So what I'm going to do instead is I am going to banish this 13 over to the right-hand side, effectively making it x squared plus 8x equals -13. And I'm not going to worry about that one so much anymore. Now let's go ahead and connect the dots one more time. So we look back at this 6 that was given in front of the x, and we look at our 9 that we had as our constant. And what is the relationship between those two and the 3 that we ended up getting? Well, pause it if you think you know the answer, think about it, and then restart the video. Our b term here is 8. The number that we want to end up with here is going to be half of that, so 8 divided by 2, and then squared, which becomes 4 squared, which becomes 16. So the number that we want here is a plus 16. Now we can't add things to the left-hand side of an equation without adding things to the right-hand side of an equation, so we balance by adding 16 there as well. What we get now is an x squared plus 8x plus 16 equal to 3. Let's go ahead and write this on a fresh page. What this now allows us to do is to say that we have a perfect square trinomial, which is going to factor into x plus 4 quantity squared. Now how did I get that so easily? I'm looking at what numbers add up to the 8 but multiply to a 16. And I had forced this to become a perfect square trinomial by adding this term right here. Half of the b and then squared. So half of b and then squared. This 3 on the right-hand side we can't get rid of, and that's okay. Okay, what that means is if we want to solve, so this is completed the square. This is our example of a perfect square trinomial. That was already perfect. If we want to solve, we can now take the square root of both sides. Now, when you take a square root, make sure you account for a plus or minus, because essentially if we say, for example, that y squared is equal to 25, then that means that y can have been either positive or negative 5. It is a quadratic and it has 2 solutions. So it could have been a 5 or a negative 5. So here I put a quick little plus minus, and now I state that I have 2 equations. I have x plus 4 equals positive rad 3, and x plus 4 equals negative rad 3. I now subtract 4 from both sides, being careful not to introduce it inside the radical because those are not alike. And I get x equals negative 4 plus square root 3, and x equals negative 4 minus square root 3. Now at this point you might be wondering, why are you doing this? Why not just use the quadratic formula? Most of the time you will be okay using the quadratic formula. It is extremely useful. However, you will see later on when you start to work with conic sections that having something in this format actually makes it really nice to work with those. Also, you'll also see later that when you have a parabola of this form, allows you to graph the vertex very easily, because now the vertex is contained right in the equation as h comma k.